Uncover the groundbreaking innovations in SpaceX's latest project as they perfect a cutting-edge heat shield for their spacecraft. Witness a pivotal moment as one flap connector breaks away, showcasing the meticulous engineering behind creating lightweight, durable, and heat-resistant tiles. Dive deep into the science as SpaceX pushes boundaries to revolutionize space travel. Join us to witness this intense moment and learn more about the future of space exploration. Stay tuned for exclusive behind-the-scenes footage and insider insights into the incredible technology powering SpaceX's mission. Don't miss out on this gripping journey into the world of aerospace engineering and the evolution of heat shield technology. So despite the recent successful landing, challenges still need to be addressed, including damage to the flap and heat shield. The Starship's fourth test flight marked a big milestone in SpaceX's history, with a successful landing after an hour and 6 minutes of flight. You know, this flight will always be remembered like the Falcon Heavy's. Nevertheless to say, it was a stunning view, isn't it? Let me know your thoughts on Flight 4 in the comment box. So back to the topic. The re-entry process began at T+45 minutes, with hot plasma flashes followed by an orange, red beam and strong friction waves. The beam gradually cleared and turned orange-red, indicating the increasing heat. In addition to the plasma beam, there were also strong friction waves resulting from the re-entry speed of nearly 20,000 kilometers per hour. A positive sign was that the re-entry process lasted longer than just a few minutes, as it had before. However, an incident occurred when excitement was at its peak. At around T+57 minutes, sparks seemed to creep through the joint connecting the flap to the main part of the ship. And then flames appeared. We could see debris and ash flying from that location. And one flap connector appeared to be completely separated from the rest. Subsequently, it seemed that pieces of ash flew into the camera, significantly limiting the view of the entire journey. Nonetheless, the flap appeared to remain attached to the ship until the end of the journey. Through a small, blurry perspective, we could see the flap moving gently, possibly due to the impact of seawater. This problem clearly stemmed from the re-entry impact. It is possible that the heat shield was affected, causing the stainless steel part behind it to directly suffer from the heat. While stainless steel is durable, it is not strong enough to withstand such harsh conditions without adequate protection. Furthermore, the flap is attached to the ship with a system of screws and bolts, making it the most vulnerable part of the ship. This led to the recent incident with Starship. Following this, many reactions emerged regarding this issue. The damage to the forward flap could have led to a nosedive, but the control software managed to adapt, and the flap operated despite missing a significant chunk during the process. SpaceX commentator Kate Tai exclaimed, "This is a nail-biter." Meanwhile, there were positive comments about the flap, such as, "This flap deserves a Medal of Honor," or "This little flap is the hero today," acknowledging the flap's perseverance in completing the journey. Elon Musk posted on X, stating, "Despite the loss of many heat shield tiles and a damaged flap, Starship made it all the way to a soft landing in the ocean." Like other parts, one side of the flap is equipped with heat shield tiles to protect it from temperatures up to 1,500 degrees Celsius during re-entry. However, the incident with the flap shows that improvements are still needed. Elon Musk also mentioned that a fully and immediately reusable orbital heat shield, which has never been made before, is the single toughest problem remaining. Being able to iterate with many ideas on many ships is key to solving this. The heat shield is one of the systems that received a lot of attention from SpaceX after Flight 3, when SpaceX first encountered the re-entry process with S-29. After every test, they monitor and even replace many parts of the system. With recent results, SpaceX will further promote upgrades to the system, including changing the layout or increasing connectivity with the ship. Everything is expected to help Starship reach its greatest perfection when landing. The transition from carbon fiber to stainless steel has been a significant decision, providing better durability and heat resistance at a lower cost. Stainless steel is considered more durable than aluminum or carbon fiber, with the ability to withstand heat up to more than 800 degrees C, whereas aluminum melts at 660.5 degrees Celsius and carbon fiber, while durable, begins to decompose at about 200 degrees Celsius. Elon Musk himself recently tweeted, "Worth noting that the ship would have failed on a re-entry if made of aluminum or carbon fiber, as they can't take the heat." This transition helps SpaceX reduce the thickness of the heat shield, thereby reducing the overall mass of the rocket. For a while now, SpaceX has been working on the vehicle's heat shield with the goal of creating a lightweight, easily manufacturable and heat-resistant tile. That's much easier said than done, however, and it seems they might have a bit more work to do. Here I'll go more in depth into the current state of the heat shield, relevant testing of tiles, Starship steel construction, and more. At its current state, Starship's heat shield needs some work. What's important to point out, however, is the fact that SpaceX is well aware of this and has been for quite a while. Even on yesterday's launch, the company purposely lifted off with 2 entire tiles missing and 1 thin tile replacing a standard tile. In these specific spots, they included extra equipment to track heating and how the vehicle would hold up in those different environments. In other words, they're still experimenting and trying to find the best approach to vehicle re-entry. Focusing more on the launch, most have seen the footage of the upper stage re-entry eventually eating through and nearly destroying Starship's flap, while we only got a view of the same flap for practically the entire re-entry. It could be assumed the other 3 flaps could have had similar damage to an extent. In this instance, the specific weak point was a seal that covered the gap between the flap itself and the main body of Starship. This is where the plasma initially broke through and then began basically eating the flap away from the inside. Interestingly, it seems SpaceX was actually a bit worried about this exact spot even before the launch took place. Specifically, in a partially released interview between Tim Dodd and Elon before the launch, Elon was quoted saying, "Sealing that hinge gap and not having hot gas just flowing super fast through where the flap hinges. Because if you get hot gas flowing through rapidly, that will cook anything, including the tiles. We got a hot gas seal at the forward and rear flap hinge, and one of the key questions is, does that seal work? We think it'll work, but it may not work," he said. This is a very promising sign as it showcases SpaceX's understanding of the vehicle. Improves their orbit unsure about the strength of the seal in particular. Beyond this, in a tweet from Musk referring to the comments he made before the launch, he said, "Not a difficult problem. We will have this nailed for the next flight." He went on to say, "Note, a newer version of Starship has the forward flap shifted leeward. This will help improve reliability, ease of manufacturing and payload orbit. The combination of the flap shifted toward the back of the vehicle relative to re-entry, along with alterations to the flap seal, could very well alter the state of Starship and keep it perfectly intact following re-entry. Similar to a lot of other developments and changes SpaceX makes to the vehicle, they usually just test it in an actual flight environment to get the data, and then move on from there. Seems like we're watching that exact process in action, but related to the heat shield. The biggest challenge for the Starship. Even though the heat shield performed well on this flight, it may not have reached its highest reliability. Many heat shield tiles fell off during flight, and were picked up by civilians. This issue compromised the rocket's safety, as evidenced by the flap being burned and severely damaged during re-entry. With these issues in mind, we can outline the changes SpaceX needs to implement moving forward. Depending on the Starship, SpaceX will definitely continue to focus on improving the heat shield system. This was confirmed by Elon Musk on X when he responded to Everyday Astronaut's tweet about the heat shield. "Not a difficult prediction, we will have this nailed for the next flight." Clearly, the issue with the fallen heat shield indicates that the connection of the tiles to the Starship requires an upgrade. SpaceX may opt to change the attachment pin system to securely hold the heat shield in place. Finally, the layout of the heat shield needs to be modified to provide more comprehensive protection, particularly for parts like the flap as seen in the recent flight. Furthermore, SpaceX should reevaluate the materials used for the tiles. In images of the recovered heat shield after the flight, we observe instances of breakage and melting. It's understandable given that the vehicle must withstand temperatures exceeding 1500 degrees Celsius during re-entry. while Starship's heat shield is in better condition compared to NASA's Orion, SpaceX's goal is complete vehicle reuse, including the heat shield. Hence, they must enhance its capabilities to minimize damage, facilitating quick refurbishment for immediate use in subsequent flights. In addition to upgrading the protection system, internal hardware also requires enhancements to prevent issues like those with the recent flap. Elon Musk mentioned in a tweet about the heat shield, note a newer version of Starship has the forward flaps shifted leeward. This will help improve reliability, ease of manufacturing and payload to orbit. With this upgrade, the flap will be shifted further towards the side without the heat shield system. This adjustment ensures that the connection point between the flap and Starship is more carefully concealed, minimizing direct exposure to the immense energy from re-entry. This enhancement significantly increases reliability and by reducing the impact of re-entry, SpaceX can simplify the flap attachments, streamlining production while maintaining flexibility during ship navigation for landing. Another system slated for upgrade on the Starship is the addition of roll control thrusters and other hardware. This enhancement will assist SpaceX in better controlling the landing process and attitude, mitigating issues such as valve clogging that occurred in Flight 3. SpaceX has indicated that they have implemented this upgrade since S-29, and after the success of Flight 4, it's likely they will continue to incorporate and refine this enhancement in subsequent prototypes. If the heat shield has problems, Elon Musk said this flight demonstrated the incredible resilience of stainless steel at high temperatures. He set the goal: we will further hone our SX300 alloy to withstand even higher temperatures. The upcoming flights will be crucial in testing the upgraded heat shield and stainless steel enhancements. SpaceX aims to conduct major upgrades to the heat shield system on the S-30 prototype, which has already undergone a static fire test. The S-30 will be the next prototype to take flight, and it is expected to demonstrate significant improvements in the heat shield and stainless steel components. The long-term goal for SpaceX is to develop a reusable orbital heat shield that can withstand the harsh conditions of re-entry without compromising the ship's structure. This technology will be essential for establishing a human settlement on Mars and enabling frequent space travel. SpaceX is also working on developing a new version of the Starship, known as Starship V2, which will feature significant design and material upgrades. The Starship V2 is expected to be more reliable and capable than its predecessors, with a more advanced heat shield system and improved stainless steel components. The development of the Starship is a remarkable achievement in space technology, and SpaceX is pushing the boundaries of what is thought to be possible. Despite the challenges and setbacks, Elon Musk and his team remain committed to their vision of making humanity a multiplanetary species. In conclusion, the Starship's journey has demonstrated remarkable resilience and innovation. While challenges persist, SpaceX is committed to overcoming them. With upcoming flights and upgrades, the Starship is ready to revolutionize space travel, making it more accessible and sustainable. The future of space exploration looks bright, and SpaceX is leading the path at its best. And that's about it for today's episode. Thank you so much for tuning in, and that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to my channel and hit the like button. And if you want to support our channel and if you want to be up to date, you can become an exclusive member, so click on our perks through the link in the description below. Thanks to watching and see you next time.